Seen how it can start to get very cumbersome when we add all of the hydrogens into a molecule like we did in the previous examples. In another example here on the right, I'm going to show you some more hydrogens again. So again, we know that every carbon atom has 3 bonds to it. And we'll start to understand these skeletal structures. At each angle, there is an implied carbon atom. So I'm going to draw an implied carbon atom at all of the ends and at all of the angles. And then I'm going to start counting the number of bonds to it and filling in the number of hydrogens as necessary. Starting from the top here, this carbon is connected to the OH next to it, and it's also connected to an atom down below. What is not shown is the bond to the 2 hydrogens there. This is starting to get pretty cumbersome. If I go down to a carbon atom over all the way to the right here, I'm going to look at that carbon atom. That carbon atom appears to have only one other bond. It must be connected to 3 other hydrogens. Sometimes you are given a molecule with all of the atoms drawn in, and we need to figure out ways to shorten that. So we will be shortening it in a couple of different ways. One is drawing something like what I had to begin with, and that's called the skeletal structure, or the line bond structure, and we will get to that shortly. Another way to shorten is by using condensed structures. I don't find condensed structures to be that useful, but you do need to understand them because you will see them on occasion. So if I'm looking at this molecule here, this molecule has 1, 2, 3, 4 carbons. You'll find out soon that this is called butane. This has 4 carbons. On the end, I see that my first carbon is attached to 3 other hydrogens. I can abbreviate that as CH3. It's also connected to carbon number 2. Carbon number 2 has 2 hydrogens connected to it, CH2. Carbon number 3 also has 2 hydrogens connected to it, that's another CH2. And then the N carbon is another CH3. It's 1 carbon atom connected to 3 hydrogens. I want you to note that sometimes molecules are written like this, but oftentimes it's going to be written in a different way. H3C on the left side, CH2-CH2-CH3. What I'm showing here is that carbon to carbon connection. So sometimes we see H3C, sometimes we see CH3. These two, these are the same. I've kind of drawn a condensed structure here, and I'm going to take the lines out to condense it more. CH3, CH2, CH2, CH3. I'm showing the carbon to carbon connection. I can also realize that I have 2 CH2s here. I can abbreviate this even more by writing CH3 in parentheses, CH2, and there's 2 of those, CH3. If I have a scenario like this molecule, I'm going to show you how I would draw that one out. I'm going to number my carbon atoms here. This is sort of out of order, but I'm going to just number them like that for simplicity. So my end, carbon number 1, this is a CH3. Then it's connected to a CH. But I have this thing sticking off of it at carbon number 3. This is called a branch. In condensed structure drawing, oftentimes you're going to draw a branch either with a line, like they've indicated here on the slide, but you don't always see that. Sometimes you'll see that in a parentheses. So my CH is connected to a CH3. And then carbon number 4, this is a CH2 and a CH3. Let me number these here according to the way I drew it on the slide. Again, oftentimes you'll see a branch in parentheses. Here's another example. So this is where on the left side, here's the abbreviation that I did before. And notice for this molecule, there's actually 2 CH3s attached to this carbon atom, right? So that carbon atom is attached to 2 CH3s. There's another way to write it, which is whoops, let me change the color here. CH3, 2, CH, CH2, CH3. And I'm going to go ahead and number my carbon atoms. So this is carbon number 1 and 3. This is carbon 2, 4, and 5. If you're noticing that there's multiple ways to do this, you are correct. That is frustrating. It is a thing in organic chemistry. You will find that there are many ways to write the same thing, so you need to be aware of all of them and be able to interpret all of them. If we are going to convert these compounds into a condensed structure, I'm going to show you how I do this. Again, you're watching the video. What I'd like you to do is pause the video here and then try to do them on your own and then watch the way that I've done it to see if you got it correct. I'm going to go ahead and I'm going to number my atoms just to keep it clear for you. There's a couple of ways to do A. For A, I can write CH3, CH, and I can draw the branch here, CH3, CH2, CH, CH3, CH3. I'm going to number my atoms. 1, 2, 3, 4, 5, 6, and 7. Again, I have CH3s right here and here attached to carbon number 2, and then on carbon number 5 I have a similar thing. I sort of have an inflection point here where I have some mirroring. Another way to write this is different color, CH3, 2, CH, CH2, CH, CH3, 2. That's another way to write this. I'm going to number the atoms for you so we don't get confused. This is atoms 1 and 3. This is 2, 4, 5, 6, and 7 are in there. I'm going to move down to B. Again, I'm going to number my atoms here just for clarity. Be aware that when we start doing nomenclature and naming, there's a specific way in which we're numbering atoms. Here, I'm just arbitrarily numbering them to teach you how to do this condensed structural formula. I'm going to keep all the atoms that are in a line and connected to each other with numbers. So I'm going to do this one. It's H, or we'll do CH3. Number one is CH3. We have a CH2 and another CH2. And then I have an O. And then I have a CH2Cl. I'll number these. 1, 2, 3, 4, 5, and here's your chlorine. I can condense this a little bit more. CH3, CH2, there's two of those. O, CH2Cl. Again, I'll number the atoms for you. We have 2 and 3 in this parentheses, 4, 5, and 6. Skipping through this. I'm going to stop this short video here, and we will move into drawing skeletal structures next. Skeletal structures are taking this complex, frankly, this is kind of a mess, right? This is a big structure. Frankly, this is kind of a mess. It's a lot of atoms connected. It's difficult to see what this molecule looks like. We're taking these two messes, or this mess here, this big complex structure, and we're going to simplify it to make it much easier for us to draw. That will be in the next video when we do the skeletal structures.